Alright, so welcome. Today we are talking about classifying triangles. Basically there are two ways that we can classify our triangles. The first is the size of its largest angle, and the second is by the number of congruent sides. So if I'm looking at my two little tables here, if I'm classifying by angle, I am simply looking at how big the largest angle is. So if all the angles are acute, we have an acute triangle. If we have the largest angle that's obtuse, it's an obtuse triangle. And if we see a right angle, then we're looking at a right triangle. If they are all the same, then we are looking at an equiangular triangle, right? So basically we are saying that all the angles are equal. When we are classifying based on the sides, having all equal sides gives us an equilateral triangle. Having two equal sides gives us an isosceles triangle. And if we have no congruent sides, then we're looking at a scalene triangle. Alright, so let's look at an example. We are trying to figure out whether KML is equilateral, isosceles, or scalene. So if we look at the picture, the first thing we probably want to do is identify the triangle that we're looking at, right? So KML, follow those three sides. What we will notice is that they marked these two sides for us. Anytime we see those markings, that means the sides are congruent. So if I have two congruent sides, I am looking at an isosceles triangle. And to state our reason, or explain our reasoning, all we have to do is say how we knew that, right? So Km is congruent to ML. All right, here's a couple of examples for you to try. The next thing we're going to look at is the Triangle Sum Theorem. We may already be familiar with this, but in case you're not, the measures of the angles of a triangle will always add to 180 degrees. Otherwise, the segments and the sides will not connect properly. So how are we going to use this? Well, basically, they're going to give us some triangles, they're going to fill in some angles, and ask us to find the missing angles. So we need to use our Triangle Sum Theorem, as well as the rules we learned previously for angles and line segments. So if we look at this, we have three angles that we need, right? We need measure angle 1, we need measure angle 2, and we need measure angle 3. So I look at angle 1, notice it's over here. I notice that I'm also missing 3 from that same little triangle. So I can't just add up the triangles I have and subtract from 180, but what I can do is realize that we've got a linear pair. So that means that angle 1 has to combine with the angle that's 57 degrees to make 180, because straight lines, just like triangles, are also 180 degrees. So I'm just going to take 180, subtract out 57, and that's going to give me 123 degrees. Alright, so then I go over to angle 2. I notice angle 2 is over here. Notice angle 2 forms a triangle with the 57 degree angle and the 71 degree angle. So if we add the two angles we know and subtract 180, that should get us the angle that we're missing. So 57 plus 71, 123, 180 minus 123 should give us 57. Sorry, 128. 52. There we go. All right, so that is angle 2. And then we need one more angle, angle 3. So again, angle 3 is going to form a triangle with angle 1 and the 28-degree angle. So we can take what we got for angle 1, add in the angle that we know, and subtract that value from 180. To get the final answer. All right, I will let you do 1B on your own. Let's move on to the next page. Okay, the last thing we're going to look at today is the exterior angles theorem. We kind of saw this when we were looking at the previous example, but what this is saying is that if you extend one side of a triangle past the vertex, the angle on the outside is equal to the two remote interior angles added together. In other words, the one that doesn't touch the angle on the outside adds up to the same thing that the angle on the outside is equal to. So if we look at this picture right here, we notice we've got a triangle. We are asked to find the measure of angle JKL in the picture. So notice we go J, K, and then L, so we need this guy. Well, to do that, we're going to need X. And we just said that if you extend the side of the triangle, the angle on the outside is equal to the two opposite corners added together. So, the angle on the outside equals the angles on the two opposite corners added together. So we should be able to solve this for X. So here we go. Okay, we know X. We look at what it was asking for. We need the angle of JKL. We don't want X, we want the angle, so we have one more step. That's right, we're going to plug it in. We should get 115 degrees. All right, I will leave that last problem for you to do. That's all we have for today, and I will see you next time.